मीटिंग स्टार्ट कर दी है, मैं करती हूँ बात। Okay, so up till now we had seen where and when to use the steel structures. So these are the different structures where we can use the structural steel as a construction material. Then commonly used steel structures. So which are the different steels, commonly used steel structures where we are going to use the structural steel as a construction material. So the first important is your roof truss. Roof truss, where we can use the roof truss. Roof truss can be used in the factories, cinema halls as well as the railways. आपने मोस्टली रेलवेज में देखा रहेगा, रेलवेज के जो शेड्स है, इवन एट द all the railway stations that are there in the Mumbai, all the local stations on the roof truss is being there. That is the different type of truss is there. That is the fink roof truss, the how truss. So there are different types of trusses that are being used on the railway stations. अगर नहीं देखा रहेगा, so whenever you visit to station you can see दो जो shades रहेंगे वहां पे ऊपर में जो use किया है, that is nothing but the roof truss, and we are going to see the design of that truss only in the upcoming lectures, as well as the crane girders, columns, and the beams. Again, these are made up of the structural steel, plate girders, bridges, transmission towers, water tanks, and the chimneys. So these are the commonly used steel structures that are made up of only steel, not RCC. Then here you can see this is a particular diagram is of the old arch bridge. Again, this old arch bridge, it is made up of the steel. This bridge is totally made up of the steel, as you can see in this diagram. Then this is your frame building. Again, this frame building is the made up of steel. It is a 2 to 3 story building. It is made up of totally steel. So these are the different structures that are made up of steel. Then the industrial building, as you can see over here, ये देखो यहाँ पे top में जो use किया है, that is nothing but the roof truss. See here at the top, mostly in the industrial buildings, the roof truss is being used for the construction. So here at the top, in each and every top, in the outer frames as well as in the inner frames, the roof truss is being used when you are going to construct the industrial building. And again, this whole the structure is made up of the structural steel only. Then this is the type of the truss bridge. Again, here also in the bridge, truss is used. Suspension bridge, as you can see in the suspension bridge, again, the structural steel is being used as a construction material. Then comes up your stable state bridge. Again, here also the steel is being used. Then again the advantages, that is here are some another advantages of the structural steel, that is the high compressive and the tensile strength per unit weight, hence low construction weight and safe space. As the strength per unit weight is high, it will save your construction weight, मतलब जो भी आपका construction का weight रहेगा वो save होगा because of the high tensile strength per unit weight, as well as good aesthetic view is there if the structure is made up of the steel, good quality and the durability, high speed of construction, reusability and the scrap value. As you know, the for the reinforced concrete, if the structure is made up of the RCC, that is reinforced cement concrete, उसका scrap value कुछ नहीं आता है. The scrap value is almost zero, that is almost negligible. But if the structure is made up of the steel, you can reuse it, and also it is environmental friendly, and the scrap value is also good if you use the steel as a construction material, as well as better solution to cover large span and the tall structure. As you know, we had already discussed that when and where the steel is to be used as a construction material. So जब भी आपको कोई भी लार्ज स्पैन या फिर ब्रिज के लिए अगर यूज करना है, सो द स्टील इज द गुड ऑप्शन फॉर द लॉन्ग स्पैन ब्रिजेस as well as any of the long span structure as well as for the high rise buildings. So it is a better solution to cover everything. Then there are some disadvantages too, that is the high cost, corrosion as well as the low fire resistance. So these are the certain disadvantages again of the structural steel. Then how to make the steel? Steel making. Steel कैसे बनाते हैं? How we are going to prepare the steel? So सबसे पहले क्या करते हैं हम? First the iron is extracted from the iron ores. जो भी आपको आयरन आप यूज करते हैं स्टील बनाने के लिए, वो आयरन ओर से सबसे पहले एक्सट्रैक्ट करते हो. So which are the different iron ore? Yes, who's this? Any doubts? So first of all, you extract the iron from the iron ores like hematite, limestone, magnetite in furnace. You extract all the ions from the iron ores in the furnace. And then the oxygen is being passed through the molten iron to remove the carbon and impurities. जो भी कार्बन और इम्प्यूरिटीज रहेगा वो आयरन में, तो उसके लिए आप क्या करोगे? द ऑक्सीजन इज बीइंग पास्ड थ्रू द मोल्टन आयन. जो भी आयरन आप मोल्ट करोगे उसमें से आप क्या करोगे? ऑक्सीजन पास करोगे in order to remove the impurities, because you have to make the steel, so the steel should be pure. So for that you are going to pass the oxygen from the molten iron. And after doing that, what you will do, एक बार अगर आपने ऑक्सीजन पास कर लिया तो आप क्या करोगे? मैग्नीज इज बीइंग एडेड. मैग्नीज क्यों ऐड करोगे? इन ऑर्डर टू स्ट्रेंथन द स्टील. स्टील को पर्टिकुलर स्ट्रेंथ देने के लिए व्हाट यू विल डू, यू विल ऐड द मैग्नीज इन दैट. After adding the manganese, you are going to add the nickel, phosphorus for the properties in the steel. So as you know, there are different properties we will discuss, which are the different properties that are there in the steel. So steel के लिए different mechanical और different physical properties रहती है. So for that different properties, you are going to add the chrome, nickel and phosphorus in the material. So that you can give their special properties to your steel. After adding those, what you will do, you will semi-finished products from the machine is being hot roll. So जो भी सेमी फिनिश मटेरियल्स रहेंगे, वो उसको क्या करोगे? आप डिफरेंट शेप्स दोगे. कौन से शेप्स दोगे? अभी स्टील की, अभी जरूरी नहीं है कि स्टील का सिर्फ बार ही बने. स्टील के वी आर गोइंग टू मेक द डिफरेंट sections of the steel like bars, plates, angles and sections. Already I think everyone is knowing what a bar कैसा दिखता है, plates, angles, what are the angles, different angle sections are there, as well as the different sections are there. So steel is being hot roll in these different type of sections. And after that, एक बार ये different sections बन गए तो उसके बाद आप क्या करोगे? Again you are going to add the carbon. Why? अभी कार्बन क्यों ऐड करोगे फिर से? In order to increase the tensile strength as well as the hardness. तो अगर आप जो आपका स्टील है, अगर if you are going to use the structural steel as a construction material, and if you are going to use it for the long span bridges and for the high rise building, तो उसके लिए it is very very important that the toughness property is very good, as well as It should be sufficiently hard enough to resist all the loads acting upon that structure. So for that purpose, they are going to add the carbon in that in order to increase the hardness as well as the toughness. हार्डनेस और टफनेस इंक्रीज करने के लिए वो लोग क्या करते हैं, दे आर गोइंग टू ऐड द कार्बन इन दैट. And after adding the carbon, what they are going to do in building, we use the structural steel which has low carbon of up to 0.1% to have the ductility and the yield. As you can see in this diagram, in the see from the first step, in the first step, iron ore, as I've told you that the iron is being extracted from the iron ore. Then the blast furnace is there. Blast furnace में वो जाता है and उसके बाद में oxygen is being added in there. Oxygen add होता है and after adding the oxygen the pouring is being done. And after pouring होने के बाद क्या होता है, it is being going in the soaking pits. Soaking pits में जाता है. Soaking pits से it is going in the bloom mill, breakdown mill, and after going in the breakdown mill, finally the wide flange beam mill is being there. And इसके बाद में जो आपका स्टील है वो बनता है इन डिफरेंट बार्स, प्लेट्स और सेक्शंस और एंगल्स, जिसमें भी आपको जो भी आपको चाहिए that is being made after this wide flange beam mill. So this is the particular process of the steel making. Understood? Anyone is having any of the query कि स्टील कैसे बनता है? Yes, everyone understood? Any doubts? I hope everyone understood. Okay, I will explain it once again. सबसे पहले what iron is being extracted from the iron ore, and after extraction of the iron ore it will be going in the after extraction from the iron ore it is being going in the blast furnace, and after blast furnace में जो भी आप iron extract करते हो iron ore से वो blast furnace में जाता है. And blast furnace में जाने के बाद क्या होता है, एक तरफ ओपन हार्थ इज बीइंग देयर एंड एक तरफ ऑक्सीजन स्टील प्रोसेस हो रही है. तो ऑक्सीजन स्टील प्रोसेस क्यों हो रही है, इन ऑर्डर टू इंक्रीज द स्ट्रेंथ दे प्रोवाइड द ऑक्सीजन टू द ब्लास्ट फर्नेस. और एक बार अगर आपने ऑक्सीजन यू आर गोइंग टू ऐड द ऑक्सीजन ऐड होने के बाद जो भी आपका आयरन रहेगा वो इधर पोरिंग में आ जाएगा. सो इट इज बीइंग एडेड इन द पोरिंग में आने के बाद में यू कैन सी इट विल बी गोइंग इन द सोकिंग पिट्स में जाने के बाद इट इज गोइंग इन द ब्लूम मिल फॉर in order to remove the impurities, whatever the impurities are there in that iron. So in order to remove that it is going in the bloom mill में जाने के बाद में वो ब्रेकडाउन मिल में जाता है. ब्रेकडाउन मिल में वो अलग अलग शेप्स में ब्रेक होता है. in whichever shapes you want the steel it is being done in the breakdown mill. And finally after breakdown mill it is being going in the wide flange beam mill. And after wide flange beam mill it is being done in the different shapes. उसके बाद में आपको जैसे जैसे शेप्स में आपका स्टील चाहिए, जैसे कभी प्लेट में चाहिए, कभी बार में चाहिए, एंगल्स में चाहिए या फिर सेक्शन में चाहिए, तो उसके बाद में आपको वो डिफरेंट डिफरेंट सेक्शंस में आपको आपका स्टील मिल जाएगा. ओके, नाउ अंडरस्टूड. ओके, now these are the different properties of the steel. So different physical properties are there as per IS 800 2007 according to the clause number 2.2.4. So different physical properties are being there of the structural steel. So these different physical properties we are going to take from the IS 800 2007. We cannot take by our own. We have to refer IS code only for each and everything when we are going to design for the steel members. So the value of R is 7850 kg per meter cube, that is 78.5 kilonewton per meter cube. And the value of E is nothing but the modulus of elasticity of steel. The value of that is 2 into 10 raised to power 5. Sorry, here there should be 10 raised to power 5 Newton per mm square. And value for the Poisson's ratio, that is value for the mu. Value for the mu is 0.3. So all the students are requested to note down the physical properties of steel according to the IS 800 2007. All of you, I hope everyone is having the notebook. All had carried their books with them. So note down all these physical properties of the steel based upon the IS code. And after completing, let me know. Yes, everyone completed? Noted? Okay. All the others are also completed? Then the next is, this one is the mechanical properties of the steel. So as you can see, the type 1 is your standard structural steel, and the designation for the standard structural steel is Fe410A. So 410 is nothing but the grade of steel. So basically there are three grades of steel, that is 410, 250. So Fe410A. So UTS, that is for the Fe410A is 410, and the yield strength, that is yield strength is nothing but the thickness in mm. So thickness is mm. Again this table is there in the IS 800 2007. So the thickness in mm, if it is less than 20, means अगर आपका जो yield strength है for this Fe410 grade, अगर वो less than 20 रहा तो उसके लिए yield strength रहेगा 250. So depending upon whatever the grade of the steel is being given in your question, you have to take the yield strength from this particular table. So this table is given to you in the IS code. You can refer the IS code for this particular table for the mechanical properties of the steel. And if the thickness is between 20 to 40, again the yield strength is 240. And if it is greater than 40, the yield strength is 230. So like this again for the Fe410B and Fe410C. So for different three grades, you are having different yield strength depending upon the thickness. Then the next is high tensile structural steel. So for high tensile structural steel, again the two designations are there, that is ST58HT and ST55HTW, but mostly we are going to use the FE grade only, not this high tensile structural steel for the construction material. For the designing purpose. For each and every design, we are going to use the standard structural steel only. We are not going to use the high tensile structural steel. Again, based upon the thickness, again, the high tensile structural steel is also having the different yield strengths. As you can see in this table, for ST58HT, the high tensile strength, if the thickness is less than 20, is 360, and if the thickness is between 20 to 40, it is 0.05, and if it is greater than 40, the thickness is 1. Sorry, and if it is greater than 40, the yield strength is 1. So no need to write this table. Already it is there in your ICE code. Now ductility. What is mean by exactly ductility? When we are talking about the high ductility in the structural steel, so what does it exactly mean? So ability of the material to change its shape without fracture is your mild steel. So the ductility involves the ability of the material in order to change its shape without any fracture. That will come in the high ductility, and for the high carbon steel it will include the low ductility. When we are talking about the toughness and the brittle material, so what does it exactly mean? What is toughness and what do you mean by the brittle fracture? Ability of the material to absorb or to resist the impact loads. So brittle fracture क्या रहता है? जो भी लोड्स एब्जॉर्व करता है, अभी कौन से टाइप के लोड्स वो एब्जॉर्व कर सकता है? द डिफरेंट टाइप्स ऑफ लोड लाइक अर्थक्वेक लोड, मशीन लोड, whichever material is having the property to absorb the load like earthquake or the machine load, that is the comes under the brittle fracture. It requires the both strength and ductility, as well as at low temperature steel fails on impact loading due to the reduction in ductility and the toughness. This is called as a brittle fracture. जब भी आपका टेम्परेचर कम रहेगा, whenever the temperature of the structural steel is low, it fails on impact loading due to the reduction in the ductility and the toughness. तब वो fail हो जाएगा due to the reduction in the ductility. At that time, the fracture that is being there is your brittle fracture. Mostly these terms they can ask in your vivas. Otherwise, in theory, nobody is going to ask you this thing. But in viva, they may ask you these things. So at high temperature, again the strength will be going to reduce. Corrosion properties. Steel is being corroded in the moist air, sea water and the acid. Steel कौन सी वजह से आपका corrosion है वो हो सकता है? Whenever the moist air is there in the environment, as well as if salty water or the sea water is being there for the on your structure, and because of the acid also. So these are the three things. Because of that, जो आपका steel structure है वो उसको corrosion हो सकता है. So for that, what you have to do, you can adopt painting, metallic coating, plastic coating for corrosion resistance. कोरोजन रेजिस्ट करने के लिए आपको ये सब चूज करना पड़ेगा in order to remove the structure, in order to resist the structure from corrosion. You have to adopt all these things. Hardness. Now next is the hardness. Now resistance of the material to intentions and the scratching. You have to resist your structural steel by providing the proper hardness to that steel member. तो प्रॉपर हार्डनेस के लिए आप क्या करोगे? ऑलरेडी यू हैव स्टडीड इन योर मॉस सॉरी सॉम. You are having SOM only. So in that SOM already you have done the practicals on Brinell hardness test and the Rockwell hardness test. That will give you the amount of the hardness. Proper hardness test is there. That is the Rockwell's and the Brinell's hardness test. With that test, you can resist the material for the hardness. Okay, understood? Any query up till here? Any of the doubts? I hope everyone had understood up till here.
Yes, ma'am.
Okay. Okay, the next is then fatigue. What is the fatigue term mean? What is fatigue? डैमेज ऑफ द मटेरियल टू द साइक्लिक लोडिंग के वजह से जो भी डैमेज होता है मटेरियल को, तो साइक्लिक लोडिंग के वजह से जो भी डैमेज होता है मटेरियल को, दैट इज नोन एज द फैटिक. मोस्टली इट ऑकर्स इन द मूविंग लोड्स मतलब जो भी आपके मूविंग लोड्स रहेंगे एज वेल एज द वाइब्रेशन रहेगा, वाइब्रेशन इन द ब्रिज. सो ब्रिज में जो भी वाइब्रेशंस कॉज होंगे बिकॉज ऑफ द मूविंग ऑफ द व्हीकल्स और द मूविंग ऑफ द एनी ऑफ द लोड और एनी ऑफ द व्हीकल, सो उसके वजह से जो भी डैमेज होगा मटेरियल को, दैट इज नोन एज द फैटिग. देन द नेक्स्ट इंपॉर्टेंट टर्म इज योर residual stress. Now what do you mean by the residual stress? So the latent stress present in the steel sections due to the uneven heating and cooling during the steel making. स्टील जब भी आप बनाते हो तब ऐसे प्रॉपर कोई टेम्परेचर फिक्स नहीं किया है उन्होंने. दे हैव नॉट सेट एनी ऑफ द प्रॉपर टेम्परेचर. सो बिकॉज ऑफ द अनइवननेस ऑफ द टेम्परेचर फॉर हीटिंग एज वेल एज फॉर द कूलिंग, जो भी स्ट्रेस आपके सेक्शंस में डेवलप होगी, दैट इज नोन एज द रेसिडुअल स्ट्रेस. And the next important term is your stress concentration. So what do you mean by the stress concentration? So under loading, stress is concentrated at places at abrupt and it change in geometry like hole bolts. So that is your stress concentration. So here we had completed the basic introduction part. Now I will show you how does your IS code looks. मतलब what is the IS code? How many of you is knowing what is IS code? किसने देखा है पहले? I think those who are diploma students, they would be knowing what is IS code and how to refer it. But those who are fresher, they didn't know what is the IS code and they are not used up till now. So just I will go give one glance that what is the IS code. See, this is your IS 800 2007 that you are going to use for this semester. That is for the design of steel structure. So this is the steel code. Basically, in this code, there are all the clauses for only steel. For RCC, you have to refer IS 456 2000. But as in this semester, you are going to study design and drawing of only steel structure, you have to refer IS 800 2007. As you can see here, there are in this here there are different chapters of your IS code. That is for first one is the general, that is the basic introductory part. Then the next is the materials. In that the different materials are there. That is the structural steel rivets, bolts, nuts, steel casting, as well as there are the other materials. Then the general design requirements. From these general design requirements, you have to take the values when we are going to design the sums. Then the method of the structural analysis, limit state design. What is exactly limit state design and what are the strength, what are the factors governing the ultimate strength. That all is there in your this section number 5th, that is the chapter number 5th. Then again, the next chapter is there, that is the design of tension member, design and compression member, then design of member subjected to bending. When we will solve the sums, I will tell you. Yes, I will share this PDF in your WhatsApp group. Then next is again the member subjected to the combined forces. Then the next is the connections that we are going to start from the next lecture itself. That is the design of connections. For that you have to refer this section number 10. That is for the design of bolted connection and for the design of welded connections. Then the working stress design. In working stress design also there are different things, that is the tension member, compression member, combined stresses and the connection, again the fatigue. So this is your IS 800 2007. So lot of things are included in this, and these are the clauses. Whenever I will told you to refer the clause number 1.3.28, you have to refer this one. Understood? This 1.3.30 is for the ductility. यहाँ पे इन्होंने बताया है what is exactly ductility and what is the definition for ductility. So the IS code, the detailed information is being provided in the IS code. See, end distance is there, design life, deflection, everything that you will require for the design is mentioned in this IS 800 2007. These are the different notations and the different symbols that we are going to use whenever we are going to solve the problems. So this is again mentioned in your IS 800 2007, the different areas and the different cross sections. So you can refer from here. Okay, understood? Any doubts? Any queries? If you are having any of the doubts or queries, you can ask. We are running short of time. We are having last 2 minutes. So those who are not given the attendance, give your attendance in the chat box and do present in the next lecture, for because from the next lecture itself, I am going to start the. Yes, I will upload it on Moodle also and I will share in your WhatsApp group also. Okay, any other query?